Okay, so we're doing the Antacid Lab, and because we want you to be as prepared as possible for this experiment, we're doing a video demo. So I'm going to go through the lab in its entirety. We're going to watch me do the lab, and we're going to see some of the technology on the screen. So I'm going to pretend that we're starting from scratch. So to do this lab, we need certain equipment. We need a reaction vessel, which will be a 100 ml beaker. We're going to need a beaker to hold hydrochloric acid, which you should label. To label, you're going to get masking tape. When you're done the experiment, you need to make sure that the masking tape comes off. That's a part of the cleanup process. You're going to use a wax pencil. I'm using a marker so you can read it a little bit better on the camera. It's enough to just put down HCl for hydrochloric acid. You're going to have 2 buffer beakers for calibrating the pH sensor. You only need to calibrate. Once you're done, you can give it to another group, or you can put it out of the experimental space. You're going to need a mortar and pestle to grind up our antacid. We're going to need thymol blue in order to use as a backup to make sure our technology is working properly. We need a rinse beaker for when we're cleaning off the pH sensor. We need barrel pipettes in order to add the hydrochloric acid during the experiment, and a burette clamp in order to fasten our pH sensor to the retort stand. And of course, the pH sensor. So to start this experiment, the first thing that I'm going to do is I'm going to set up the workspace. So the pH sensor, when you first get it, it's going to be all attached. So I've already disconnected it, so I'm going to disconnect it again just so you can see. And this cover, we don't want it to get into the beaker. So we're going to pull the cover slightly up the shaft, so that way when I put it into the beaker with all the antacid and hydrochloric acid, it's not going to get dirty. The next thing I'm going to do is I'm going to clamp this to my retort stand, and it just gives me some stability. So my retort stand, you might have a different size, which is perfectly fine. Normally I clamp it and I twist it, and that just tightens the bar on the retort stand. And then I'm going to push the jaws together and just going to flick the screw, and then I'm going to twist this so that it's the right angle for me. I'm going to put the jaws of this clamp, I'm going to squeeze it tight, and I'm just going to spin this back. So it's nicely clamped, so now I have some stability here. And so when I want to lift this up and down, I'm just going to loosen it, and then I'm going to clamp it. You'll be working with a partner or a group of 3 or maybe even 4, so someone else can handle this for you while you're doing the lab. Once I have the pH sensor connected to my retort stand, I'm going to turn it on by hitting the on button. I know it's on because it's going to flash red, and then it's going to be flashing on the Bluetooth symbol. And now I want to connect it to my computer. So you'll be using your device on your phone, but because of the video demonstration, I'm going to do it on my computer. The computer application looks exactly like your phone app. So once you've opened up the application, hit the middle button, and you're going to go to the Bluetooth symbol, and I'm looking for my pH sensor. So as you might recall, each sensor has its own ID. Look at the last 3 digits, select it. It's going to say connecting. There's a possibility it might ask you to update the probe. I suggest that you do not, because that might take up to 5 minutes, and it might even take longer. Once this is all set, then I can close this Bluetooth window, and I'm going to select the top right option. That gives me a graph and a data table. Now I need to set up my application in order to record the data properly. By default, SparkView will allow you to take a graph that's based on time. So as I add or change whatever I'm doing in the experiment, it's going to go up and down based on time. I don't want time, I want it based on the number of drops. So in order to change the variables here that I'm using to collect, I'm going to click on time, and over here on the right hand side, I'm going to select user entered. I'm going to create a data set, and I'm going to give it a name. So it's going to be based on the number of drops. It just so happens that my measurement name and my unit name are pretty much the same thing. For measurement name, I can say number of drops, and for my unit name, I can say drops, but I decided to call them both the same thing to keep it short. I click OK. I now have user entered data. Next thing I want to do is I want to make sure my graph here is also showing number of drops. So pH versus drops. So I'm going to click on this little graph symbol. That's going to minimize my toolbar. I'm going to click on the time, and I'm going to select user entered, and I'm going to select drops. So now my x-axis is drops, and my y-axis is pH. Finally, the default is collecting data based on time. I want it to collect data when I tell it to. So I'm going to click on this little symbol. I'm going to select manual, and I'm going to select OK. So now my data will only be collected when I tell it to. There's a check mark, and every time I want to collect the data, I'm going to select that check mark. You'll see a little bit later. Now that I've set up my application, I'm ready to calibrate my pH sensor. So I'm going to leave this for a moment, and I'm going to come back. So I have my pH buffer beakers, 4 and 10, clearly labeled. Do not put them in blank beakers because they might get mixed up. I did color code them, so the pH 4 is now yellow, the pH 10 is blue. You'll likely see a beaker like this, or a bottle like this somewhere. That's where you get your pH 4 and your pH 10 from. I've already poured it into these beakers. So my pH 4, I'm going to place on my reaction space. I'm going to take my pH sensor, I'm going to drop it into the liquid. Generally speaking, I don't want my probe to be moved when I'm calibrating. Now that I'm setting the pH buffer 4, I'm going to go back to the computer, the application. I'm going to select the screwdriver tool, and beside the pH is a little target. I click on this, and it's going to give me the calibration screen. I click on continue. The value I'm currently using is a standard value of 4. It's been sitting there for over 10 seconds, so it's good to go. I click on set calibration. I come back over to my pH sensor. I lift it up, I lift it out, move my pH 4 out of my workspace. I'm going to go to my cleaning beaker. I'm going to rinse it off. And then I'm going to go to my pH buffer 10. So this is important. So we talked about acids and bases already, and we used indicators, we used pH paper. So this is another technique we can use for measuring, but with a probe, you have to tell the probe what the correct values are, and that's why we use these buffers. We have to give it 2 points, so then the computer application can then use an algorithm and determine the pH correctly. So now it's been sitting in 10 for a while. I confirm that my standard value says 10. I let it sit for about 10 seconds, which I've done. I hit set calibration. I click OK. I click this little close arrow. I can maximize my screen. And now I have a data table, and I have this graph. All right, so it's ready to go. I'm going to take my pH sensor out of the buffer. I'm done with my buffers, so I'm going to give them to somebody else if they need them. I'm not using them anymore. And I'm now ready to think about my experiment. So what you were supposed to do is you were supposed to determine which antacid is the best. And because this antacid is in a tablet form, it's not going to react very well. It doesn't dissolve in water readily. We have to work on it. So this is a brand new container. This is my Tums Peppermint regular strength 500 milligrams. So it tells me a lot of information. I've read the instructions here, made up my hypothesis. I'm going to take out a tablet. My balance, which you can't see the numbers on it, I'm going to weigh it. Now, when you're doing this, my suggestion is that you use a paper towel, you fold it, place on the balance, hit 0, take your tablet, weigh it. I can see that it is 1.3 grams, so I record that somewhere. When you're running the experiment, you'll notice the instruction said to do 0.5 grams. Because it's a decimal or a fraction, the math at the end can be a little more difficult, but the experiment will go much faster if you use half a gram instead of a full gram. Because it's 1.3 grams, the easiest way for me to ensure that I get 0.5 grams is I put it in this mortar and pestle. The temptation is to hammer it, but that's not what you do. You grind back and forth. I'm going to grind it until I get to a nice powder. So you'll see a powder. Now this, we do not want any breaking in the class. If I put it on the tabletop, because it's a cylinder, it will roll. And if it rolls off the table and hits the ground, it will break. So please make sure that you give this to someone to hold on to, or put it in a place where it will not roll off the table. So now I need to measure 0.5 grams. I'm going to take this little weigh boat that I created from the paper towel. I'm going to put it back on the balance. I'm going to make sure it says 0, which it does. I'm going to take my antacid. I'm going to put on my paper so I see 0.5, 0.3, 0.5. Right. This is 0.6, I did a little too much, so let's take a little bit off. There we go. So now my 0.5. On my reaction vessel, which is not labeled, which is fine, in the instructions tell you to use 50 mils of water. That's why we're using a 100 ml beaker. So 50 mils of water. So to measure 50 mils, your most accurate way is to use a graduated cylinder. So I didn't show you the graduated cylinder at the beginning, so my apologies on that one. For this experiment, when you use antacids are taken with tap water. So at home, you'd use tap water. At school, we have access to distilled water or tap water. You get to choose which one you want to use. If you use the distilled water, you can take this off, but absolutely do not put this down on anything because the table might be contaminated. It will contaminate our bottle. So hold it or hand it to somebody else to hold on to. Pour your 50 mils. I'm going to pour about 45 mils, and then I'll put the lid back on to get to 50 to make sure I'm accurate. So notice I did not put it down on the tabletop. So I'm going to go to eye level. So I'm at 50. I pour that in my reaction vessel. Now this powder does not mix very well, so just be aware of that. Okay, and my stir stick. So I pour it in. It's nice to get a little vortex happening in here as I pour it, and that will help it dissolve a little quicker than if I just pour it in and then stir it after. It's possible that some of the antacid you use will not mix very well. You also might be using a colored version of an antacid, so it might be red or pink or green. Next, I'm adding thymal blue. So the thymal blue is an indicator, and the thymal blue changes color around a pH of 2. So I'm going to add a few drops. So I've added 5 drops. And you probably can't see from where you are, so I'm going to come a little closer. And maybe you'll see it on the camera. But when I added it, you might see that it's slightly blue. I went from this red to this blue. So you might see that's a little off blue right now. So what will happen is I'm adding acid to this reaction. When it gets close to pH of 2, this beaker will start to turn closer to this color. And that will tell me I'm close to the end of this experiment. Okay, so I'm done with my thermal blue. Now I can drop my sensor into the solution. I'm going to try to put it as close to the side of the beaker as possible. I'm going to come around, or your teacher's going to come around, and they're going to give you some hydrochloric acid. It's 1 molar. Now at this point, you're using something that is more dangerous. Up until now, everything has been household. So it's very important that you're always wearing your safety goggles. You might get a warning. After that point, you'll probably asked to sit down and not participate in the lab. So you're wearing safety glasses to protect your eyes, mask to make sure that you're not spreading COVID, if that was a possibility to protect you. So I have my hydrochloric acid, and I have my barrel pipette. So, back over here on my application, I'm going to hit start. My first value is 0. So I hit 0, I double clicked on it, or double tap on it, 0. So I know my starting value is 10, which is expected. It's an antacid, so I expect it to be basic, alkaline of some sort. So now I'm going to add until I get to 25 drops. I know that when I do this, 25 drops for me is about a mil. This is where your partner is going to help. And so as you add a drop, they're going to be stirring. So I add this drop. When I get to a pH of 2, I want to stop. Now, the way I have the screen set up, you cannot see your value currently. So since I started at 0, I'm going to click on this check mark, and the check mark is now locked in my starting value of 10. So my starting value of 10-ish is 0. Now as I add my drops, you're going to see that 10 is going to drop to something that's more neutral and then acidic. 1, 2, 3, 4. And your partner will be watching the pH value, and they'll tell you if you get close to 2, and they'll tell you to stop. Can you tell me when to stop if you see it close to 2?
Okay.
And if you can just watch me doing this. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I just put in 25 drops. I've mixed it. I see that I'm at 5.5. So I'm going to say 25 drops right here. 25. And I'm going to hit the check mark. So now it's locked in. So every 20 or 25, I think 25 is a good number, you're going to lock it in. So now I'm going to go with the next 25. But if it gets to 2, I'm going to stop. 1, 2, 3, 4, 5, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Mix it up. And so now at 4.7, click, 50, enter. We'll keep on going until I get to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. We're at 4.37, so it's not shaking all that much. It's probably because there's a lot of chemical that wasn't reacted, kind of sitting at the bottom of the beaker. Now I'm going to add a little faster because you get the gist. So I know the 1 mil mark, for me, that is 25 drops. So I'm at 76, 77, 80, 85, 90, 95, 100. All right? 100. So I just hit enter to keep. All right. And now the next 25. If I look at my beaker, what you'll notice is that it's starting to turn pink. So I know I'm getting close. You might be able to see that it's kind of a little bit of a pinkish hue. As that pinkish hue tells me I'm getting close to the end. Because my thymal blue turns reddish pink around the pH of 3, 2.5, and so on. So I know I'm getting really close. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, There we go. I'm going to leave it at that. So it's right around 2. So I had 16, so for this last one, I'm just going to say 116. 116. And so now I'm done. You'll see this kind of weird graph. I'm not going to use this graph, but I just did that so I can do a comparison from one run to the second. So I'm done with run 1. So run 1 was regular strength. So now I'm ready to do run 2. So when I'm done with this experiment, I'm going to hit stop. My data will be in this chart. When I go to the second experiment and I hit start, it's going to do run 2. And I'll just show you what it will look like. So I'm going to hit start here. And so see how run 1 disappeared because it's no longer checked. Run 2 is now highlighted. And so now I can do the exact same experiment running it on run 2. If I want to see run 1, I just click on this button and I'll be able to see run 1. If I want to see it on the data table, I can select run 1 from the titles on the top of the column. So I'm always able to see all my runs. In terms of my experiment, I'm going to run at least 3. You'll notice my pink at the end. I'm done with everything that's here. If I'm done with my experiment. If I'm done with everything here and I'm done with my experiment, then I'm ready to save my data and export it. In order to export the data, I'm going to... All right, so I decided to do a screen capture here so you'd have a better idea of what you need to do once you finish collecting your data. So once you finish collecting your data, on our sample we only have run 1. We do a run 2, but it's not a true run because we stopped it, right? So in order to export the data, you're going to click on this menu. You're going to click on Export Data. If you're on your device, you're able to export it in several different ways. I like saving it as a CSV file. If you're on your device, it will probably allow you to send it by iMessage, by WhatsApp, by Dropbox, by whatever. You choose the one that's appropriate. If you're using a school computer, I don't really have much of a suggestion for you. You'll probably have to use the Google Dropbox. You have to make sure you're logged in correctly. If you're not logged in, then you'll not be able to get rid of the data and you'll be kind of stuck. So hopefully you did that in the first place. Make sure if you're using a school device, you log in first. Otherwise, you'll not be able to get the data off easily. So I'm going to export this. I'm going to call it export data erase me 2021. All right, so I'm going to save that. Okay. And then I'm going to show you how to import it. So I'm going to go to Excel. I'm going to go to File, Open. I always look to see where you saved your work. I think I might know where I saved it. I might have to double check again. And then I'm going to go to Documents. I'm going to go to Spark View, My Spark Data, Saved Work. I'm going to click on All Files so I can actually see it. Erase me 2021. So I'm going to import that. And so here's my data. So some of this I don't need. The date and time, that's not important. So I'm just going to delete that. Time, the time's not important because we did not do a time experiment. So I can delete that. Voltage is not important. It is a voltage pH probe. So that's why you have this voltage running here in the background. So I'm going to delete that. And that leaves me with run 1 and the number of drops. If I had run a run 2, or run 3, or run 4, they would be up here as well. And after this, I can then highlight my information. I think you will know how to do the next part about inserting graphs, so I'm not going to run a video on how to do that. Okay? And that's the experiment.